Hello, welcome to Talk Julia. We're recording Friday, May 13th. My name is David Amos.
And my name's Randy Davila.
Randy, I am absolutely thrilled this week because we have a very special guest on the show. Viral Shah, welcome to Talk Julia.
I'm glad to be on the Talk Julia podcast. Thank you for having me.
Yeah, it's a real honor to have you on the show with us. We've been, this is I think the fourth interview that we've done now, so we're still kind of figuring out how these interviews work and been inviting some people, but it's really exciting to have one of the co-creators of the Julia language here with us. So Viral, to kick things off, why don't you talk a little bit about how you got into programming and computer science, and maybe lead in a little bit then into how you started this whole Julia movement that's happening.
Yeah. So, oh gosh, when did I start learning how to program? So I actually grew up in Mumbai in India, and my school in eighth grade had a computer programming computers class, and it was not a standard what we call a board subject, right? So as in when you take your board exam in the 10th grade, there's no computer science in there. So most people did not take it very seriously, but I was just fascinated, and I was introduced to BASIC back then. I think it was GW BASIC, if I'm not mistaken, and that's how I started. And I kept programming in BASIC all the way through into high school. In high school, we did have a computer science elective, and the interesting thing was in my high school that you could, what we would have called college back in Mumbai in the 11th grade. And if you could make it into the computer science program, then you could avoid taking biology and a second language. And I was like, this is a win in both ways. I get to spend more time programming and less time doing things that I'm not that interested in. But I kept doing a lot of BASIC was a really interesting environment, and QBasic especially that I discovered later. By that time, also the big thing that influenced me was my parents actually bought me a 486. It was a DX2 back then, and so now I had my own personal computer, and I could just I just kept getting drawn into the world of programming. Like it's like as you can imagine, for someone who's young, that like it's just a world with infinite exploration, and you can type things in, and then they happen as per your command. And QBasic was really cool in that it had lots of graphics and all kinds of stuff. So I went through high school teaching myself physics by programming it. So that was sort of my first foray into scientific computing as well. I just found that I learned physics better if I programmed it all.
Yeah.
So that's the basic story, and then it's just one thing led into another. I decided to follow computer engineering for my undergraduate in India, and decided to go for a PhD in computer science at UC Santa Barbara, where I again focused on high performance computing for my thesis. And it was there that I met Stefan, and soon after graduating, I met with Jeff at the startup that we were working at together. It used to be called Interactive Supercomputing, later got acquired by Microsoft. And it was at that point we were like, it's just so frustrating what the state of numerical computing has been over all these decades. So at that point, I had been doing some form of numerical computing for practically 10 years at that point.
What language were you using at the time?
So in my thesis, throughout all my undergraduate and my thesis work, it was largely C, and then in my PhD, the system I built was actually a parallel MATLAB. There's a project at MIT that Alan Edelman had started. It used to be called I forget. I think it is called MIT MATLAB. It later on became a company. It was called Star P. And the idea was you put a star P in front of a few variables, and then those get automatically distributed. So it's a really cool system.
I like that.
That was my thesis work. So that was sort of a MATLAB front end to a large C and MPI parallel backend.
So that's interesting because there's actually a lot of similarities with my own story there, in the sense that I also got started with BASIC and QBasic in particular, and it was like a total accident because my parents had bought this like 386 computer, and it had a couple games on it. This one of them, I think it was called like Gorillas BAS.
Yeah.
And do you remember that?
Yeah.
And I remember, I don't remember the exact line of thinking it happened, but at one point I ended up opening the file like in a text editor and saw all this code and was like, whoa, what is going on here? And there was a comment at the top of it that there was like a game speed variable, and it had a little comment, like change this number to change the speed of the game. And I changed it and then exited and ran it as the game, and it, the speed was changed, and that just blew my mind. I could just change a number and change all this stuff in the game. So yeah, I dabbled in QBasic for many years as a young kid, and like you said, it just felt like infinite possibilities and endless stuff. So that was also my own introduction into programming.
I still feel there isn't an environment as productive as that for someone, getting into programming, right? Because you could write code, you could do graphics, and
Yep.
especially the ease of graphics was just amazing.
Yeah.
And I still don't think today's systems have that. Like Scratch is infinitely more like accessible and easier to learn, and it has a different kind of graphics. But this just like all I needed was the primitive plot this point at this point on the screen with this color, and I could just build anything I wanted. Like it was powerful. It was pretty powerful.
Yeah, absolutely. Yeah, I mean, my parents have commented to me many times of how they would just be shocked that I would spend hours and hours and hours just sitting there trying to figure out how to do something, and they couldn't believe how dedicated I was to it and everything. So yeah, it's nice to meet a fellow QBasic. I love her.
I think one of my cousins at one point then handed me a book about the original K&R, the Brian, the Kernighan and Ritchie.
Yeah.
And he's like, you might want to learn this C thing, and then I was then like, oh, blown away at this. At that point, I'd already received Linux.
Okay.
So this was late 90s, and in India at that point there used to be this magazine called PC Quest, and they would ship CDs. So you'd get like Slackware CD, Slackware Linux, and I got that thing installed, and I was like, wow, this is a crazy new world. And then I had this K&R book, and I learned C, and I was like, wow, my programs are like infinitely faster than what basic. And it just kind of kept drawing me in. And I remember getting to, if I remember, it was chapter number 4 on pointers, and I was like, okay, this is just a whole new thing now. And it's just like the rabbit hole kept getting deeper and deeper.
Right. Yeah. So I'm curious to know what you mentioned, that you were unhappy with kind of the state of numerical computing, or there are things that were frustrating about it. What were some of the things that you all found frustrating?
So it is what we call the two-language problem today, right? The term didn't exist, and we actually coined it several years into our work on Julia, because we kept getting asked this question, like, why did you create a new language, and why should the world care? And we needed a succinct way of sort of capturing the sentiment with which we started. And it was basically that, until Julia came along, you had to write your algorithms in something high level. It often used to be MATLAB back then. R had sort of started getting really popular. Python was just about beginning to make an appearance, and was going to soon get into sort of, it's crazy, ramp up.
Yeah.
But we were like, look, you cannot write high performance code in any of these systems because you always have to drop down to C. And my own world of computational scientists, was not people who came from computer science who would have known C or Fortran as a given, but these are people who were working in MATLAB or R or Python was not that popular back then yet. But it was just frustrating to see that people had all these ideas. They wanted to sort of, write these basic models and simulations and so on. And they were restricted by their own, by the limitations of the tools rather than by their imagination. And as a computer scientist, I knew that, they could go 1000x better. And I have an actual real story that actually spurred me into this direction, which is a project that's called CircuitScape. It's still very alive today. Started in 2001 with my collaborator, Brad McRae started it. It was originally in Java. He could not hack Java. He was an ecologist. So he he somehow learned enough MATLAB and put it in MATLAB, and it was barely running grids of 100 nodes or something, right? So think of a landscape of 100 pixels, right? Like it basically can simulate your parking lot, if at all.
Yeah.
And then, so he used to be at Santa Barbara, which is where I went for my PhD work, UC Santa Barbara. And he heard about this, PhD student in computer science who has a parallel MATLAB. So he's like, my MATLAB is really slow. Why don't you use your parallel MATLAB, and then I can solve bigger problems? But then we started collaborating, and it took a year for me to understand what he was doing and for him to, understand what I was doing. And then it turned out that we could just rewrite the entire code in MATLAB and make it like, 1,000 times faster. So we had the first system. But to run it, you needed MATLAB, and no one had MATLAB. So we then did a transition to Python, which then became completely open source. And that could run at much larger scale now because I had sort of reworked all the algorithms and all that. But I still could not do everything I could in order to get the program to work as fast as it ought to be. And finally, in 2015, I think, or 16, we got a grant from NASA to move it to Julia. And it's just screaming now in performance. And so in some sense, my own pain points around, like, I want to write this thing. I know what it can be in C++ or C or whatever, but Brad could never hack that code. But if there was a language that was sort of like high level, but also high performance, it would make sense. So that was the takeoff point, right? And I suffered through this in my own PhD thesis. Stefan had a very similar story. He was doing a lot of linear algebra for signal processing wireless data, and he was using actually a mixture of Ruby and Perl and C. And then Jeff was sort of always a language designer, and he came at it from a traditional computer science Lisp perspective, like just languages can be better and what we have isn't good enough. So we just got a thread going. I remember this was in September 2009. Like, hey, the world needs something better. And then in 2 days, the first line of Julia appeared. There's not much more thinking than that.
Wow.
I definitely remember those days when I was in grad school at the CAM, the Computational and Applied Math Department at Rice. Grad students would often start with some physics problem or some like signal type of problem, and they would model it in MATLAB. And then to get to their dissertation, they had to transfer it to C or C++ to make it like actually like usable.
Yeah.
And I remember seeing, and I wasn't a part, like I was in the department, but I wasn't doing much computation at all. But I remember seeing it all over the place, just headaches of, like they have it working in MATLAB, but it's like months before it's ready in C++. Actually, I'm reminded of a talk that I saw there. One of the grad students gave a talk on Julia, and this was in 2013. I think it was version 0.6. And he gave a talk on it and was like contrasting it with MATLAB and like saying all these good things. And then he happened to like say something negative about MATLAB in the talk. And in the audience was a professor named Danny Sorenson, who was a part of like LAPAC and yeah. And and he immediately was like, nope, MATLAB's still good, but I like where this is going.
Well, I am the author who packages Danny's ARPAC code into Julia.
Danny's he's a really funny professor. I used to play blues music at this blues bar by campus on Wednesdays, and I saw him there one time, and he did a cheers. He was like to Eigenvalues.
Yeah, that sounds like it. That sounds like it. I think that message would resonate in the Julia community.
Yeah, for sure. So you started Julia in 2009, and I'm trying to kind of think. So in 2009, I wasn't really, well, I was still in college, and I was studying computer science, mainly C++. So I hadn't even started using Python really at that point. And I'm not really familiar like what the state of Python was in 2009.
It was rough.
Yeah.
Especially for numerical computing. Not the Python language is all well formed. But NumPy was still in its early years. SciPy was a shadow of what it is now.
Yeah.
I wrote CircuitScape in Python around then. And it was difficult. It was extremely difficult. Like the graph libraries were not there. The sparse solvers were not there. And you could not drop down into Python syntax and write your own low-level kernels, because then that would just run at like pretty bad speed. So
Right.
but enough of it existed that we were able to find a path.
I do consider myself at this point mainly a Python programmer. I mean, that's where the vast majority of my professional experience has been over the last, I guess, about 8-ish years now. And, when I started learning Julia, which was not that long ago, I wrote my first code in Julia back in January of this year. But I really felt like, coming from a Python background, there were so many things that just clicked instantly getting into Julia. And I know it's not an exact, there's not like a one-to-one map between the syntax or anything, but it really, I mean, within the first week of me kind of going through the docs and learning the language, I was doing pretty complex stuff in Julia, and it just felt like it was a really rapid transition into it. Was the Python syntax, or some of the philosophy around that, a big influence on the Julia syntax, or what were some of the thought processes going on there?
I think the syntax is broadly sort of, I would say it's less Python-like, and if you have to sort of pick familiarity, it's closer to, MATLAB, Octave, Scilab, like those
Yeah.
kinds of languages. Um, we were very clear from early on that we wanted one-based indexing because that's what made sense mathematically.
Yeah.
It's a perpetual internet discussion topic,
Sure.
as you already know. Um, um, and then, I think many of us were just not sort of big fans of the white space kind of base syntax that Python has, and so we thought that it was not the right way to go. At least that's how we started. And there was a lot of I would say that a lot of the early ideas actually are more functional in nature. So Jeff especially comes from I mean, MIT Lisp kind of crowd. And I would say that style of thinking was probably more dominant than Python was. Like, remember, like when we started, and like if we started in 2009, but our views were formed maybe even 5 years building up to
Sure.
2009, and Python was not a thing in that world yet. I mean, it was beginning to get there, and I would say that Python was sort of learning from the same legacy in some sense that we were, right? And there were sort of these two different uh, things happening at the same time.
Yeah, actually, I hadn't really thought about that, because when I was in graduate school, I used MATLAB quite a bit, and actually I taught like seminars for undergraduates to use MATLAB. So there was that experience, which probably helped in just get me picking it up as quickly as I did. And the whole one indexing thing. So my very first professional programming job was with an audio visual company here in Houston. I was programming like control interfaces and automation and stuff for them, and it was all done in Lua. So and that is a one based index, and that always just felt super natural to me, coming with, because my background is in mathematics. I have a degree in mathematics. I was at graduate school studying mathematics. So yeah, it felt really natural, and that was one of the hardest things for me when I started learning Python, was just like getting that, like, okay, yeah, everything starts from zero. Like that really was a really difficult mental shift for me. And in some ways, that aspect of Julia kind of felt like, like putting on a familiar, like comfortable slippers or something. Like just kind of like, okay, everything kind of feels more natural now.
That's how you learn to count, right? Like, as a child, right? Also, right? Like, and if you look at, like, Fortran is one base, for example, although you
Yeah.
can do arbitrary indexing in Fortran, and you can do arbitrary indexing in Julia as well. I mean, there's a two indexing package. Right?
Are you familiar with the Star Wars arrays.jl?
that was made, I believe, by Mose Giordano, largely as a as a way to like throw some fun into that argument. But
Right, like it doesn't really matter. That's just
but yeah, I would say that, like, Fortran for me was a bigger influence. Like, I was like,
Okay.
this is what we need to do. And There's this beautiful video of the guys who actually designed Fortran. Like, I mean, I think you can find it on YouTube, and it is a wonderful video by John Backus, where IBM made this video probably in the 80s or something, interviewing the Fortran team. And if you listen to that, it sounds like if you remove the words Fortran from it and just replace them with Julia, it could be the same thing.
Yeah, I'll definitely check that out. I'm always watching YouTube videos, so
this is real gold.
how about C? How much influence did C have on the early design choices? Because sometimes when I look at the syntax, I get that C feeling. I don't know.
I say less of C, but like, you know, you probably get a different answer if you ask Jeff or Stefan, right? Right. I think the thing, the original Why Julia blog post, the Why We Created Julia blog post that we published on in 2012, like actually articulates it, that there's actually a lot of different languages that all of us used over time, and we sort of synthesized ideas from, you know, all of them across the board. So some of the low level stuff, especially if you're working with pointers and doing pointer arithmetic, chasing. So the underlying model. So actually, you're right. So the reason why it feels familiar to see is all your structs, right? So when you create a Julia data type, you create a structure, struct, you create arrays. That whole thing maps pretty much one-on-one with C, and that was deliberate because we needed to be compatible with C. We wanted to be able to send Julia data structures to C and C data structures back into Julia, and it was pretty obvious that that was the way to do it. And doing, having LLVM and Clang sort of in that ecosystem made it relatively easier to do that. So that's the one thing you don't get in the other high-level languages, right? The user-defined data types and that tight control on memory layout. Like, you could not define this effectively in. I mean, you can do these things in every language, but they're not, high performance as they are in Julia.
So currently, you are the CEO of Julia Computing, correct?
That is right.
So how did Julia Computing get started, and what's the story there, and yeah, tell us about that.
So we started, so there were four of us who started Julia, right? So myself, Jeff, Stefan, and then of course Alan Edelman, who housed the whole project at MIT and kept funding it, no questions asked. Even as everyone, including ourselves, believed that the world would, maybe not adopt a new language. And the key point here is we knew it's a 10-year journey to get to the starting line, right?
Yeah.
We started in 2009, so I would say that we released 1.0 in 2018, right? So, and that's when I think we're like, okay, now we are in the race, whatever the race is. But
right,
my mental model is that you have maybe a couple of languages that get adopted in a decade, right? Like in some broad way, right? Now I feel like this decade, the 2020s, potentially, like Julia was like the kindergarten version, right? Like it was emerging. I think this is this decade now that you're at the starting point, you can emerge. And you kind of saw that happen with R and Python in the last decade, and maybe right. JavaScript and Java in the decade before. So they all have this 10-year gestation period. I would say, if anything, Julia sort of, because of GitHub and the internet and everything, was able to grow faster than languages that started out in the 90s or the 2000s.
Yeah.
And so it was sort of, so that was one observation, right? That this is it's when you start something like this, you have no idea where it's going to go. You started as a hobby, and like, I think the world would be better if this thing existed. It doesn't exist, so that's how you get started. But then sort of when it starts building upon itself and it starts getting traction, then come the next level of questions like, okay, this is great, but now how do we make this self-sustaining and go for a long time? And it was clear that we could not do this in an academic environment forever, because you're constrained by grant money. Grants kind of have this ebb and flow, and they sometimes there's a lot of it, and then sometimes it disappears, and people can't build their careers around something like that, right? And on university stipends. And so it was clear to us that at some point there has to be some other solution. We didn't know what it would be. But the other data point was that languages are not commercializable unless you are Google or Oracle or Microsoft, with an exception. And the exception was languages for data science or anything analytical, right? Where the businesses have been tremendously successful. First one being SaaS, $5 billion in revenue. MathWorks is a great success, and there's a lot to learn there. And increasingly, our studio and Anaconda have been trailblazers in the open source language businesses that now sustain a lot of the innovation in those ecosystems. So, back, in about 2015, we were standing at this crossroad of like, okay, we can't do this stuff at MIT, especially if we have to support customers commercially. And that's when, the four of us, along with two other co-founders, Ken Fisher and Deepak Vinci, came together and said, let's start Julia Computing. And that's how we got it off the ground. Having no idea what the business model would be, having no, it's just just out of the sheer belief that this is important and we need to, do it. That's how we started.
What is the business model as it stands right now?
So the business model has evolved considerably over time. When we first started the company, we were, like, hey, this is an open source company. So we are going to do a lot of consulting and training and then keep writing Julia on the side. And that's, in fact, how we founded the company, right? Like we started receiving some early contracts from finance firms, from Intel was a big backer in those days. And so that's how we got started. But we very quickly realized that if we are a consulting and training shop, then we are sort of helping everyone else. But Julia itself is not, going forward. And if we don't work on Julia itself, then that's going to suffer.
Yeah.
So that's what led to the, our seed round. So Donald Fisher, who was back then an investor at General Catalyst, it's right around here in Boston, in Cambridge. And, he had reached out, he had connected to us all way back in 2013 saying, guys, there might be something here. But we were like, no, it's too early. We need to build out the community. We need to think this through carefully. So, but when we were ready in 2016, he was like, let's do it. And we started the company imagining that there will be some kind of, product business that we build. Now, we knew that in the first few years, we still had to focus on the open source project and the community without even thinking too much about the business, which is what we did until we got to 1.0 in 2018. And that's when we started sort of taking stock of like, okay, there's, let's look at the world around us. Let's see, what's going on. Let's see what the role of Julia in that world is. And clearly, the cloud had taken off. I mean, it was taking off. It had taken off. Snowflake, for example, was right out there, like, growing rapidly. And you've seen several open source projects build a go-to-market using cloud-based offerings. And that's when we started down the same path as well. And so that's our broad business strategy today is fairly straightforward, right? Support the open source project and still continue to drive it and innovate there along with the community. Take that to enterprise customers on the cloud. So Julia Hub is our cloud system on which we think is the best way for people to run Julia, right? Especially at large companies. People are working from home, working from any device. Increasingly, people are running workflows in their browsers on the cloud. Even the IDE lives on the cloud. Press a button, run your programs at scale, like, Julia's distributed computing, GPU computing. Just make it easy, right? I mean, yes, technically every developer in your organization could figure this out, but let's make it nice. Let's make everyone productive and let's make it reliable, scalable, all that good stuff. And as we have been going down that path, one of the things, we also started out was a partnership with our colleagues at Pumas AI, which is a pharmaceutical company, a pharmaceutical software company. And, we work very closely building a modeling and simulation tool for pharmaceuticals. And then we started, doing the same for multiphysics simulation and circuit simulation over the last couple of years. So we sort of saw this path of like, not only can we be on the cloud, but we can have this, suite of modeling and simulation tools on top of it, so that scientists and engineers who want to work on these kinds of things don't have to start from scratch in Julia, but they have something substantial to work with. And so that's sort of our go-to-business, go-to-market motion. And a lot of the underlying software and tools are open source. We've generally not done weird open source licensing. So we strongly believe that there will never be like an open core Julia where Julia Computing has the better optimized version, or like,
Right.
like the GPU backend you have to buy from us or something, right? Like, we've been very clear that that needs to be completely MIT licensed and open source. But then there are, value-added tools and services and products where, which are meant largely for professional use, which do not have large communities behind them, but have large buyers and users. And so we felt that that was the right, dividing line, that like there's an open source ecosystem, and then there are products that we build on that, just like many other companies build commercial products on Julia, relational AI being one of them, Beacon Biosignals, Invenia. I just met with the guys at Hafnium Labs, so it's just phenomenal to see that, and we have a couple of those ourselves as well.
Yeah.
So that's the broad story.
What has surprised you the most about like the Julia story, the Julia adoption, or like has there just been anything in particular that you're like, wow, we never imagined that something like that would actually happen with the language?
I think that's the biggest one, right? And I always share this anecdote from Steven Johnson, right? And so, everyone probably knows Steve Johnson, the author of FFTW, professor at MIT, and one of the sharpest guys I know. And I would say that, and also a core Julia contributor, by the way, and a Julia steward.
Okay.
So, back in 2009, we started the project, and I would visit MIT every year, as part of a collaboration, like, 2010, 11. And we'd go off to Steve's office. It used to be right next to Alan's back then, when there were offices, I suppose. and,
Yeah.
and Steve would be like, "This is amazing, but you're doomed to fail." And we would all be like, "Of course we know that, right? Like, that's the default answer, right? That this is gonna
Yeah.
go nowhere." And then I'd go the next year, and then he would have like, "You're probably doomed to fail," and then you're like, "You're really doomed to fail," and but he would say, "But where this might head," and you're like, "Absolutely." But at some point, he saw my FFTW wrappers in Julia, and he was appalled at what I had done, and so he got in there and did it the right way. And he was like, even though this may not go anywhere, I'm having a lot of fun doing it. Maybe he'll have a slightly different version of this story, but I think that captured the sentiment that you just don't take this lightly, right? Like, you just you do it for yourself, and to solve a scratch and itch that you have, and the fact that when we announced it with that Why We Created Julia blog post that ended up going viral on Hacker News and Reddit that day. It was accidental, right? Like, none of us even thought anyone's going to read it. And we posted it, and Stefan was on vacation. I was asleep. It was nighttime in India, and it just blew up. And from like, it went from like being a 4 creator project, 4 people who built it, to being just like an overnight, like we were at 100 serious contributors within the next 6 months.
Wow.
Like, off that blog post. Like, that's how powerful that was. That to me was the most surprising. From that point on, it kept compounding.
I just wanted to ask if Alan brought his corgi to his office ever.
I think he does. He has been for the last few years that I have known. So yes, that's and he brings him to the class as well.
I've never heard about this. Does he have a famous corgi or something?
Yeah. So if you go to his class, computationalthinking.mit.edu, you can see that Phillip the Corgi makes an appearance in all.
Oh, okay, gotcha.
Notebooks.
Yeah, he's always like in the background or barking, or Alan's using like image decompression on corgi pictures.
Okay.
Philip is as much part of the Julia community as everyone else, I think.
Yeah,
That's funny.
I agree.
An appearance at the next JuliaCon, not this one, but the next one, I assume, which is going to be at MIT.
Oh, nice.
So
Awesome.
we are hoping it'll be co-located with Alan Edelman's 60th birthday celebration conference. So a mixture of both, his math life and his computer science life.
Yeah, that'd be great.
So one of the things that surprised us the most, because this started out, we've shared this story a couple times on the podcast, so I don't go into all the details, but we this was just a hobby sort of passion project, and really just a way for me. I wanted to learn Julia, and Randy had been using Julia for a couple of years, and he was like, why don't we just do something public about it, and do this podcast. And we like didn't know if anyone would actually listen to it, and we weren't like really marketing anything about it or anything, and it just seemed like instantly, like we released an episode and the very next day there were like 100 people that were like kind of swarming around it, like, oh, this is awesome, like we've wanted a Julia podcast for so long, and everything. And I, for me, I guess that was the most surprising thing, is just how passionate and friendly and welcoming and the whole Julia community is, and how quickly we were just sort of like accepted into what feels like this family of people. And it's been really, heartwarming and just amazing to see. And we've just met so many uh, amazing people
Yeah.
through it. So the community seems to be just incredibly strong. And I've been a member of the Python community for a while, and Python has sort of this uh, you know I guess famous sort of community around it, and similar, but I guess it's grown so big at this point that I don't know, maybe it was more like Julia was back in maybe the early 2010s or something. There was a similar kind of feeling. I don't know, because I wasn't a part of it at that point. And while the Python community has certainly been welcoming and friendly and everything, I just hadn't experienced the level of passion that I experienced with the people in the Julia community. So that has been a really fun thing to see and become a part of.
That has been what has been most enjoyable for myself as well over the years, right? So you asked me about what are the things that were surprising. So this for me, I would say has been the most, like having someone like, for example, a neuroscience professor like Tim Holey becoming like spending so much of his time and becoming like a core contributor to Julia. I mean, like in what world would that connection
Yeah.
exist, right?
Yeah.
And like I mean, and just the kind of people who've been attracted to the project, the friendships that we've created, that we built over the years. The fact that many of them actually work at Julia Computing, and like this is like their career now, and the fact that like it's this collective mission that we all started with, right? That the world can be better if there's if we have more computational tools that right, like computation, in my view, computation is the answer to the challenges that we face today in the world. And it's not the only answer, but it's a part of the answer, right? Like whether you're
Yes.
building
Yeah.
your next batteries or your next renewable energy grid, or whether you're designing your new electric vehicle, or what have you, right? There's so many of these things, new materials. We're designing new air conditioners with our colleagues at Mitsubishi Electric. There was a fantastic story around a new crash simulation platform that one of our other customers is collaborating with us now. It's going to be a talk at JuliaCon, and it's just seeing sort of these kinds of things, right? The fact that we can drive industrial innovation and sort of cut down those design times, right? Bring machine learning into science. I just feel like, that mission has been sort of crafted by the community at large together. It's something that we started, but, it could not have been what it is without like someone like Chris Rackauckus driving this entire scientific machine learning ecosystem, for example, right?
Yeah.
And it's those friendships and collaborations, and I think those have been the most fruitful and fun parts of this. And I'm sure that similar things exist in all other communities, but I, I would be biased, but I have not experienced this in other communities myself, but I'm greatly biased.
I'm really curious on that note, because you were mentioning so many things about computation, right? And that's like computation and data science. These are the things that like interest me. But it seems like there's a fairly good chance that Julia is going to end up eventually being used for more general purpose types of things down the line. Already, like if you look at the packages that are being created and registered, you see some like web development things. You see all sorts of things popping up, and I'm curious to see over the next 5-10 years what's going to happen.
It was always meant to be more general purpose than say R or MATLAB were, like that. We were very
Right.
clear about that from day one. So that's why we always had like a asynchronous. So like we've always had coroutines, for example, or we call tasks in Julia. We've always had socket programming, distributed computing, all of these things that you would not associate with a language of this kind.
Yeah.
But it has been surprising for me, like the fact that someone like a company like Relational builds a whole database in Julia. I mean, that's crazy, right? If you think about it and step back from something that started off, in the academic world as it did, but the fact that like something as core and robust and deeply systems oriented as a database, or the fact that like Adrian has built this, Genie framework, right, which is a web framework.
Right.
Yeah.
That has been another surprising thing for me. Like I knew that Julia could be used for those things. We knew that we had designed it so that it did not exclude those things. But but the success of multiple dispatch, like the tremendous success, like where it's 100x better than other primitives for all forms of numerical computing, right? I personally wasn't sure if the 100x transplants to like writing a database or a web framework.
Yeah.
But it seems like it does increasingly, and I would say that has been very surprising for me, but pleasantly surprising, right? And
Yeah.
it would be great to see that mature and grow.
We recently interviewed Bogomil Kaminsky about his Julia for Data Analysis book, and he gave an example that he has from the book where he's got some data that gets read in and does some sort of simple analysis on it, and then serves some sort of visualization for that data on like on a website using the Genie framework, and it's the entire pipeline is in Julia. And when he was showing this to me, kind of in the back of my mind, I was thinking, yeah, I mean, I've done similar stuff like that in Python, but then it dawned on me that the major difference, though, is that when I do that in Python, I'm using libraries that under the hood are leveraging a lot of lower level languages like C or C++ or something to do some of the analysis or whatever. When you go look at these libraries that he was using to do that in Julia, they're 100% written in Julia. There is no other language involved. And to me, that is the major difference and the powerful one, because I've personally run into issues where, I come across some edge case or a bug or something, and then when I go to investigate it, I find that it's, there's something written in C++, and it's like, I don't have time to try to figure this out or whatever. And, you leave a bug report and hope maybe something will happen with it. But with Julia, and granted, I'm not a Julia expert, but I at least know the language that I'm going to read. So if I come across something, I go look, and so much of it's open source, if not 100% of the stuff that we're...
It goes back to your gorillas.base example, right? Like the fact that it's written in the same language that you're sort of, comfortable with. And
right. Yeah, exactly. And so, it's so much easier to just sort of go in and, okay, I see what's going on here. And then, of course, the extensibility, it's so easy then to sort of write your own patch for it to move along and get going. And then obviously, if you're a responsible citizen, then you can, carry that upstream and everything. But yeah, I mean, that level of just being able to look at things at all the levels, and it's all the same language. I've never experienced that before. And I think that's, for me, is just one of the coolest things about the Julia ecosystem, that everything that I've touched so far has been 100% Julia, so I can just dive in as deep as I want to go and be in familiar territory.
Alan has a beautiful phrase for it. He calls it Julia all the way down.
Yeah. Yeah.
I was maybe curious about like the early days of using Julia. Like, how did you interact with it? Was it so? I remember, what was it? Atom was an IDE when I first started looking at Julia.
Oh, yeah.
And then just using the REPL. But I was just curious, I guess like maybe Vim or something, or what did you use early on when you interacted with Julia? And also, the REPL is awesome, by the way. So I just have to say that I love the Julia REPL.
The REPL was in there, like, in the first few commits already. Like the REPL has always been there, along with the logo and the start screen that we see. They've like literally been there from like day one, practically speaking. The REPL was not that nice in the early days, so we used to wrap it around, with this utility called RL wrap, so that added readline kind of, facilities on top of this thing. But very, very quickly it got some readline integration, and then that eventually got replaced with terminals.jl and all of that stuff being done natively in Julia. And then, I personally did, wrote everything in Emacs myself. And because I started that long ago, I think my muscle memory is still tied to Emacs for Julia, and I haven't found myself in the VS Code world. But I did adopt the notebook, so I started using a little bit of Jupyter at the time when that took off. But of course, that's Pluto notebooks now, and that's how that's progressing. And especially for those of us who work inside the Julia, inside the core of Julia, like you can't use the tooling that is built for people who work like using Julia, right? So that's part of the challenge there.
The REPL has been, I think, when I first got the interest in, okay, maybe I should learn Julia, it was still kind of like, I don't know, I'll dabble with a little bit and kind of see what happens. The REPL experience pretty much just sold it to me immediately. Where I was kind of like, wow, I just want to use this for everything. Like, I just wish everything were were this nice.
The REPL is insanely good, and people have made it like really. Like I learn about new REPL features all the time, and you can get quite far before you have to move to an editor, right? Like that's how I
absolutely. And again, it kind of goes back to, like you were saying, with Julia all the way down. I guess it was shocking to me, coming my history with other languages and other interpreted languages or that have a REPL and things like that. You sort of have certain expectations when you have a REPL, but you also sort of expect a lot of limitations, because that's just what they just always have lots of limitations. And so, for example, in Python, the standard Python REPL is okay. It's certainly, like, it gets the job done and you can do a lot with it. But to really be productive, I found personally that you have to move to something like the IPython REPL.
That's what I do. That's the first thing I install if I want to use Python.
Right. Yeah. And if the package management story, which, I mean, we don't need to get into all of that, but and it's come a long way and it's gotten a lot better. But it sort of seems like, okay, you're going to use Python, then you need to go grab this other thing over here for your REPL, and then you've got to go grab this other thing over here for your package management. And it's not just like install the language and you're ready to go. And so that was, again, it was something that when I started using Julia, it was like, wait, I've got this REPL. I was like, wait a second, this is like just as powerful, if not more powerful, than the IPython REPL, and it's just the one that comes with the language. Like, it's
default.
It's amazing. Yeah, that made me, because I spend whenever I program, I spend the vast majority of my time in the REPL. I love the interactive programming and everything, and so that just immediately, it was like, okay, this feature alone has convinced me that I'm probably going to use the language for something, and it sounds like that was a large part of the story from the beginning. That was something you wanted, was a solid REPL experience.
It was very much there from the beginning, and it was incrementally worked on to become what it has. I mean, we always knew we wanted it. When you're used to the open source ecosystem, like you kind of, and if you're a command line person, which all of us were, then we knew that, like, the other answer, the other side to it is like, you have a beautiful IDE, and then you do everything through the IDE and clicking around with the mouse and all that stuff. And yes, that's nice to have, but not at the expense of having a really powerful REPL. Like, I personally don't like getting my hands off the keyboard when I'm programming. Like, I don't want to move to the mouse. So, and I think a lot of the early developers felt that way, and that's why the REPL just became like as powerful as it has. Like, it's a pretty fully featured IDE, if you ask me, of its own. I mean, stretching it a little bit, but
I mean, it's close.
You get the REPL and you get Unicode plots, and you're done.
Right? Yeah, exactly. Well, and also just the fact that the package manager is just a part of the language. I mean, it was something that was like so refreshing, and that is sort of like an official package management story, like just from the beginning.
This was I would say that one of the things that we saw with Python early on, where we were like, this just does not seem like, this seems like a problem that we should address in Julia, and Stefan was very clear about what it needed to be like, and he spent years building the package manager. And then after we built the package manager, we had to go and build the whole package server infrastructure, which is not as visible. But for example, there have been packages that have been like GitHub repositories that go away or orgs that get deleted, and you don't even notice it because it's all in the package server cache. If it was licensed and registered, if it was an open source license and registered, that lives on in the registry. And upstream changes, like you don't get the LPAD incidents, for example.
Right. Yeah. That's exactly what was coming to my mind. Yeah.
We just yesterday discovered a package that had been deleted from the registry, and I was like, "Oh, this is not not from the registry, upstream, right? The upstream project or org, for whatever reason, got renamed or deleted, didn't exist. If you click on the actual GitHub project page, it doesn't exist. But if you go pkg.add it actually just comes through as if nothing changed. And so anything that depended on it would not break. And I was like, wow, right? Like we just sort of did not face this problem because it was designed, to avoid this altogether.
I would not be surprised if those aspects of the language are key factors in growing adoption in outside of like the numerical and scientific world. I don't think many people have sort of gotten there yet, but as Julia becomes more and more, I guess more people become aware of it. I would not be surprised, because that was just my immediate reaction, was because I wasn't really coming to it from like a numerical scientific. I was really more just like a curiosity standpoint of like, I kind of want to learn this language, and it just the it just felt so good and so comfortable that it was just kind of like, I can't imagine every time I work in another language now, I'm going to miss all these things, like, and so, and those are powerful emotions that would, if you have the opportunity to say, I want to choose this language for this project I'm starting. If you just feel that good about the ecosystem or the tooling around it that exists, that's just native to the language itself, then that's probably going to help you or greatly influence your decision in it. So yeah, I wouldn't be surprised at all if those features sort of become important factors in adoption in other areas.
I think Rust did some very interesting things with their package management. So they're also, they've also sort of learned from the past things and done, a very good job. And I believe people from the Julia community have taken some of the learnings and brought back, right? So for example, like there's Rust up for installing like different versions of Rust and all that.
Yep.
There is now Julia up, and we are hoping that it becomes the standard tool and how people install Julia, because while there's a great package ecosystem, installing Julia itself is like a little bit of a manual process, and you have to get, and Rust up Julia up does what Rust up does, out there in the Rust world. And so it's just, the world is just moving and continuing to evolve, and it's great to see sort of, the Julia community learn from other ecosystems. And I also see the reverse, right? We see other ecosystems learning from us in the way we've done things.
Yeah.
I've been seeing some chatter around the Fortran, mailing lists and stuff around where, like, how, they're talking about like, hey, there's some lessons to learn from Julia around how we position a numerical computing ecosystem, and they're doing some pretty amazing work out there.
That's got to be an interesting feeling as one of the co-creators to see those discussions going on in like very well established communities. Are like, wow, something we made is having an impact in those areas. I imagine that's probably a little surreal even. So looking forward, to the future of Julia, what are some things that you see, like really and positive things that you are looking forward to, and maybe some challenges that you see in the future?
Those are very good questions, and so I'm. And this is my personal view of what I think Julia is and where it will go. And of course, the truth is that it's a union of what all of us want. But I personally have always been driven by science and combining my love for programming and science into this world of computational science has been really awesome for me. So I'm excited about that. The one of the things that I'm most excited about is that direction where we keep pushing the state of the art in what computational simulation allows us to do and what impact it has on the world. and the fact that Julia Computing is at the center of it is able to, um, build the kinds of products that no one else is building or imagining. That's just amazing in my mind, and like not to dive deep into the products or the strategy, but just that broad idea of computation sort of saving the world at some level is what really drives me forward and then excites me, and I think a lot of the people in our community think the same way, right? Like there's so many people who want to contribute. There was that original article back in 2015. Gosh, I forget. About what can a software engineer do for climate change. And if you read that and you look at everything the Julia community and Julia Computing have achieved in the last few years, it's pretty much like everything that is listed in there. And that is a very comprehensive, blog post by Brett Victor. Um, and I would encourage everyone to read it. So that's, I would say, sort of articulates a lot of what excites me and what I think where our place in the world is, what our purpose is, and the fact that Julia Computing can keep driving it in that direction from a commercial standpoint, in addition to all the amazing things that we are doing as part of the broader community.
Yeah.
There are many challenges, and like one of the problems is that when you're sort of building these things and when you're on the inside, you only see the problems.
Yeah.
You never see the all the amazing things everyone's doing. So every once in a while when I go to a conference and I meet someone and they say, oh, look at this amazing thing I've done in Julia, and I'm like, wait, this thing actually does work. But one of the things, especially for modeling and simulation workloads, we need to fix is the way our compiler works. There are a lot of compiler passes that are maybe quadratic time or worse, where the person who wrote those never imagined that a simulation person's gonna throw in a basic block of 1,000,000 lines of code. They're like, oh, how much could a human write? Maybe 1,000 lines. Okay, this quadratic algorithm's fine. And then come these auto-generated tools, right?
Yeah.
Like all these DSLs in Julia, where you can generate like millions of lines of Julia code by writing just like a for loop or something.
Yeah.
And it stresses the hell out of the compiler. And so finding those and fixing those is a huge priority, which will also improve the broader compiler speed and compiler experience for all use cases.
Yeah.
Whether you're building a database or a website, all of this will kind of come back to that. Another thing that I have been discussing with Stefan and Jeff extensively, and we'll hopefully get time to get to that, is separate compilation, which is today you sort of build your Julia program as this one big system image, right? And in my mind, and not everyone agrees with me, but in my mind, one way to sort of scale the use of Julia in an organization is to have larger teams working on different parts of an application all in Julia. And I think separate compilation is an important part of enabling that. That if everyone has to build this gigantic system image every time they change a line of code, that's going to be difficult. So tooling around incremental system images, separate compilation, tiered jittering of Julia programs so that you start interpreting while you're compiling in the background. So you remove that latency, compilation latency that everyone talks about a lot.
Yeah.
I think these are some of the key things in scaling Julia, not in terms of running Julia programs at scale, but scaling the way teams of people work on Julia themselves. I think these are some crucial fundamental things that we'll be working on over the next few years. In fact, I mean, these are large projects, right? If they were quick, they could have, if it's low hanging fruit, we would have picked it already. So these are the things that I think need to happen in the core, and there's a lot of thought going into it, and there's gonna just be more and more of this. So by no means is the language done and like closed. I mean, in some sense,
Right.
there's years and years of language design, language improvements. I mean, I think broadly we are there on the actual syntax and APIs. I mean, that will see some changes maybe, but under the hood in the compiler, and to enable all of this, there will be version 2.0 and a 3.0, which won't just be cosmetically different, but like fundamentally making huge strides in the way we evolve as a language and as a community and an ecosystem.
Yeah.
and I think it ties back to the larger mission. So when someone fixes something at the compiler, it changes the climate simulation code and makes it possible to do things that were not possible before. So in my mind, this is one of the few places where you can see a direct linkage from low level work in the compiler or library to its impact on meaningful contributions to the world.
Well, we want to thank you so much for joining us today. We do have a couple of questions that we ask at the very end, all of our guests. One of them you've already kind of answered. So the first one we usually ask is, if you're going to write some Julia code, what do you use to write it?
Okay.
And it sounds like are you still using Emacs primarily, or
Emacs and increasingly VS Code?
And the second one is, what is your favorite Julia package? And I know it's hard to pin it down to one, but
it's hard to pin it down. There are so many good ones, but something about Unicode plots is just too elegant for me. So I'm going to pick that one.
That's a good one. That's a good one.
It's just too cute and too amazing of an idea that it has to be my favorite package, I would say.
Well, and what's interesting is there's been a lot of sort of focus and interest around the terminal lately in a lot of different ecosystems. I'm not sure if you've been following there's a Python project called Rich and Textual, which is focused on making really beautiful like TUIs, text user interfaces in the terminal. And there's the term.jl.
Yes.
I don't know if you've seen that has come out in Julia, which is, I know, heavily influenced by Rich. There's also I can't remember the name of it now. A project they just released it, made it generally available. I want to say it's called like Fig or something like that, which is almost like it's like a really powerful autocomplete for the terminal. So, and I don't know what language it's written in or anything. It's general purpose tool that you install in like in your terminal. It's interesting how over the last few years, it seems like there's been a lot of effort put into making the terminal a more beautiful and better experience. And so we might see something in the near future where you can do like all of your data analysis and visualization just in the or maybe not all of your visualization, but a good portion of it, in the terminal. So Unicode plots might be an early step in that direction.
That's a good point. I think that's a fantastic observation. I hadn't personally pieced sort of this trend together, but I'm gonna go back and look at all these projects now that you mentioned. So this is great.
There's a lot of interesting stuff going on there. It's fascinating to me because it seems like in some sense like a regression, but in a really new way. Like it's a really like, let's go back to this sort of old technology, but do something really, really unique with it. Because a lot of software developers and software engineers spend a significant amount of their time in a terminal. So why not make it a better experience?
Well, I mean, and it, new technology is old technology, done in a new way, right? I mean, Elon Musk is, going back to space, something that we did in the 60s, but, and now it's being done in a modern way. And terminals are sort of much of the same, right? In that respect, or languages and compilers and pretty much everything that we do. I mean, it's interesting to sort of watch that, progress, right? And how much remains the same, but then also, how much is new.
Well, Viral, thank you so much for joining us. It's been an absolute pleasure having you on the podcast. We look forward to maybe running into you at JuliaCon.
Yeah, thank you for having me. This has been wonderful.
Yeah, we should have another one. I really want to ask you more about your linear algebra loves, I suppose.
That would be a fun one to have, and I think there are many others in the community who might also be very interested in talking about about linear algebra and graphs and the connections in these worlds. I mean, and that community is now increasingly participating in Julia. So it's just amazing to see that.
Well, thank you so much. Thanks for talking Julia with us, and we will see you soon.
All right, bye.
See you.